what you need to know about them. Let me just sharpen my pencil. Now you're going to need your compass for this. So let's see. Construct a bisector of a given angle. So let's put that down. Okay, so here's what you got to do. We're going to be given an angle. So as a matter of fact, I'm going to draw what we're given in pen. And you should also. So let's do like 2.5 inches. And same thing here. 2.5. Okay. So this is our given angle, right? Now my construction lines are going to be drawn in pencil. So the first thing we do is we put our compass point on that edge there, and I move this just so it's right about halfway in the middle of my angle, and I draw an arc that crosses both sides. Then I can use this same distance and I put it on that intersection, and I put a little arc out here in the middle, and I go to this the other intersection and I put the same type of an arc out here in the middle. Okay, those are my construction lines. And now my bisecting line should be in pen, and it goes right through the middle like that. Construct a bisector of a given angle. Okay, so there you have it. All right. Oh, that's card number 22. Now for card number 23, we want to construct the perpendicular bisector of a given segment. And this is card number 23. And here's how you do this one, or here's what this one looks like, I should say. Right about in the middle of my card, I'm going to put a 2-inch segment in pen, because this is what's given to me in the problem. Okay? Now my construction lines will be in pencil. I put my compass on the left end, and I make sure that my my hole is about somewhere in between halfway and to the end. I would go like right in the middle, or I would go 3/4 of the way from one end to the other, and I make an arc just like that. Okay, then I go to the other side and I will do the same thing. Alright, now you draw the line that's bisecting the segment. Just like that. Okay? That's that. The next one says construct a line parallel to a given line through a given point. Okay, and this is number 24. So let's turn it over and do that. So let's say we have a given line. I'm going to draw this in pen because it's the given line. I'm going to go most of the length of the card. I'm going to put arrows on the end because it says a given line, so this really should be a line. And through a given point. So I'm going to draw now a given point in ink, in pen. Okay. Now I will draw the construction lines. First you draw a transversal, just like this. Then you take your compass and put it right on that intersection, and you put the compass pretty close, okay, and you make a small arc, okay. Then you go to that top intersection point and you make a small arc there, and you go to, whoops, when you make this first arc, you need to also do it from this point. And then when you make that second arc, you also do it from that point. And then you draw a line through that point and this point. And lo and behold, the two lines are now parallel. So you need to show all of that, and if you don't, then you won't get full credit. Alright? Now let's see number 25 here. Is construct a line perpendicular to a given line through a given point. And for this one we'll say when the point is on the line. Okay? So let me just see if try to remember this one. Okay. So again, we have to draw a given line. And for this one, the given point is on the given line. So that stuff should be in pen. So first what we do, okay, is we put our compass on that point and we make an arc that crosses both sides of the line, just like that. Okay? Doesn't have to be too big or too small, just something similar to that. Now I take my compass and put it on that intersection, and I'll extend this a little bit, and I make an arc out here, and I come on the other side, and I use the same distance, and I make an arc like that. And my perpendicular line will go through the given line, and it will be perpendicular. Okay? Now we have to, and that was 25, so now we have to do 26, which is going to be similar to this one, but a little different. We're going to construct a line perpendicular to a given line through a given point. So it says the same thing. By the way, this is number 26. But this time in parentheses, when the point is not on the line. Okay, let's see what this one looks like. So, first things first, we have draw it a little higher up than that. Maybe even like right there. Okay, so I'm drawing the given line. But this time my point is not on the given line. See, it's floating around somewhere else. Okay? Now we do something pretty much the same, but I'm going to put the compass point on that given point, and I'm going to make an arc that crosses both sides of the line again. Okay, this time my arc was on the other side, but it doesn't matter. Now I go onto that intersection, and I make an arc out there somewhere, and I just use the same distance on the other side and make the same type of an arc. Just make sure they cross, and now I go through this point and this point. And this gets done in pen. This is my my line, my perpendicular line. Okay. So that's it for the perpendicular and the parallel stuff. Now we're on card 27. Okay. And we need to construct an equilateral triangle. Equilateral triangle. Let's see. Period. And then under, in parentheses next to it, when given the segment length. Okay, so what we're given is the segment length. So at the top of the page here, I'm going to put, let's say they gave us a segment about this, like this, and I'll put here, you know, given segment, because sometimes they give you the segment. Okay, so I'm putting this in pen because this is what's given to us. Alright, so this is what we do. We draw a reference line okay, in pencil, and I'm going to put a point on the leftish side of the reference line. Now I measure the segment with my compass, and I put a little arc here to show that I measured it. Okay. And I put an arc like that. And then I go from this side and I do the same thing. Whoops. Yeah. And now you can see all your points should be in pen, and your triangle should also be in pen. So this is the first type of construction you could be asked to do for an equilateral triangle. They can give you the segment length. And notice how I'm going over the part of the bottom line, reference line, with the bottom of my triangle in pen. Okay? So this is when they give you the segment length. Now, for the next card, this is 28. Let's put construct an equilateral triangle. And now we can say when we are not given a segment length. Really, it should just say when we are not given a segment, but no big deal. So, what happens then is that you draw your own segment. So this one I'm going to make 2 inches long, and I'm doing it in pen, notice, because I'm making my own segment, right? And then I'm going to write segment. Okay, and I'm going to draw my reference line, and I'm going to do the same process that I did for the last one. But this time the only thing in pen will be my triangle. Okay? So let me measure this segment. Just go like that. Make sure you put your little line there to show them where you're getting the length from, okay? Because otherwise you won't get credit for it. Okay. Okay. Now, that's it. Now, we did learn another way to do it using the circle method, but it's not necessary. Okay, so I'm not going to include it in the Regents review. I'd rather you just, this way is a little easier, so I'd rather you just remember this way. And that's the end of the construction stuff. So now we'll move on to our next set of cards. Okay, this is card 29, and we're going to talk about medians. So a median of a triangle is a segment joining any vertex to the midpoint of the opposite side. Okay, so let's turn this over and draw a median. So first I got to draw a triangle, because when we talk about medians, we're talking about triangles. Okay? So here's what I'm going to do. I'm going to draw the base of my triangle, 4 inches long. You don't have to do this, okay, but this is what I'm doing. We're drawing any triangle really that we want, and I'm going to make the point of my triangle a little off center. This is the standard triangle that I draw. It just looks like your basic triangle. It's a basic scalene triangle where all the sides are different lengths. But that doesn't really matter. You draw any triangle that you want. Now, I made this side 4 inches long, right? So I'm going to put a little mark at the halfway point, because now I'm going to label the vertex, each vertex of my triangle. These are vertices, these points here. So this is vertex A, this is vertex B, and vertex C. Now a median goes from a vertex to the midpoint of the opposite side. So I'm going to draw in one median here. And I'm going to call this point D, and I'm going to label this line median. Okay? So now what's special about a median is that since it goes to the midpoint, it cuts this side in half into 2 equal parts. So this is congruent to this. So we can write two statements down. We can say segment BD, all right, that's segment BD, is a median. And we can also say that segment AD, which is this piece on the left, is congruent to segment DC. Okay? So that's what a median is. And that's card 29. So let's put that aside for now. And I'm going to go to card 30. Okay. The point where all three medians of a triangle intersect is called the centroid. Okay. The centroid divides the medians into a 2-to-1 ratio. Let's put the piece of the median closest to the vertex is twice as long as the piece near as the piece closest to the midpoint of the triangle's side. Okay? Now let's see what this looks like. Okay. So, once again, I'm just going to draw a very basic triangle. Okay. Same type of triangle I usually draw. You can draw any triangle you want. Just make it pretty big so that everything in the diagram is clear. Okay, so we have medians, right? So if I'm going to look at this side here, my median that's going to go to this side is going to go to right about there. So here's one median. Okay. Now, the one that's going to come to this side, I'm going to use centimeters here. This is about, let's see, 6.4, so I'm going to go to 3.2. That's halfway. So this median goes from that vertex to the midpoint of this side. Just like that. And the median from this vertex will go right through this point of intersection to the middle of this side. Let me just mark off where the middle of this side is. This side is about 8, so I'm going to 4. And as you see, it lines up perfectly, as it should. Okay. So I have my 3 medians drawn. Now, let me just label this triangle. This is vertex A, vertex B, and vertex C. And let's call this D. Let's call this E, and this F. Now this point is obviously the centroid, right? Where all the medians meet is the centroid. Now, remember, the medians cut the sides in half. So we know that this side is equal to this side. And we know that this piece is equal to this piece. And we know that this piece is equal to this piece. That's from the definitions of medians that we talked about. Okay? Now we also know that this right here is the centroid. Okay? And now the other piece of information that we learned about, let's call A, B, C, D, E, F. Let's make this point G. Okay? So let's say look at this last statement on the side. The centroid divides the medians into a 2-to-1 ratio, right? So, and it says the piece closest to the vertex is twice as long as the piece closest to the midpoint. So, in other words, see how this is the piece closest to the vertex? If this was, say, 10, this little piece would be half as big as that. This would be 5. Okay? And let's say this big piece here was 16. Then this little piece would be 8. It would be half of that. And if we said this piece right here is, I don't know, 12, then this little piece here would be 6. Okay? So that's an example of what happens when medians intersect at one point. Okay? Let's put that aside and go to card 31. Okay. We're talking about altitude here. The altitude which is also the height of a triangle, is a segment from any vertex perpendicular to the line containing the opposite side. So let's see two different pictures of how this works, okay? I'm going to draw two different triangles. This will be the base of my first one, and then this, that will be the base of my second one. And I'm going to draw a standard triangle on the left side, an acute scalene triangle. Okay. And on this side, I'm going to draw an obtuse triangle. All right. And let's say this is A, B, C, and this is A, B, and C. Now for the first triangle, it's very straightforward. Okay, the altitude will go straight down to the opposite side. From the highest point of the triangle, straight down to the opposite side, and it's perpendicular. Okay, let's say this is point D right here. So for this one, BD, segment BD is the altitude. Okay? For that one, it's very straightforward. And by the way, the altitude doesn't necessarily cut this side in half. And for the triangle that I drew, it doesn't. For some triangles, it does, for like an isosceles triangle or an equilateral triangle, but in any other triangle, it doesn't cut it in half. Okay? So BD is the altitude. Now for the other triangle, it's a little bit trickier. All right, now I have to draw a straight line down from B straight down. All right, so what I'll do is I'll just extend this side with a dotted line just to show where it would be. So I just draw a dotted line like that. And my altitude will go straight down from that point to the ground that's even with the bottom of my triangle. Okay, and this is a right angle. And if I call that point D, it's the same thing. BD, segment BD is the altitude. Okay? So that's what an altitude is. Now, let's do another card. By the way, we have to number this card. This is card 31. And our next card is going to say the point where all three altitudes intersect is called the orthocenter. Okay. The orthocenter may be inside or outside of a triangle. Let's put, this is card 32. Now I want to just quickly go back to card number 30, and let's just put, this is card 30, the centroid is always inside the triangle. Okay? The centroid will never be on the outside, but the orthocenter can be on the outside. And we're going to see two different examples, one where it's on the inside and one where it's on the outside. So for my first example, I'm going to draw a triangle, a standard triangle, an acute scalene triangle. All the sides are different and all of the angles are different. That's like a typical triangle, looks like that. There's nothing special about it. Now, I'm going to draw all three altitudes. So you may be asking yourself, what do you mean? I thought there was only one. No, there's really three, depending on how we're looking at the triangle. I mean, if we hold it straight up and down like this is an altitude, right? That's the one you're thinking about. And this is perpendicular. But now what if we turn the triangle this way, right? Well, we can draw an altitude here also. Okay. Like this, right? And this is perpendicular. And then we can turn it this way and we can draw this altitude, which in fact would go straight through that point there. Okay, so this point where they all cross, all right, is called the orthocenter. Now there's another case, all right, where we can have a different type of a triangle, like an obtuse triangle. Let me just check something here. this. And in this case, you're going to see that what will happen is that the altitudes will meet outside of the triangle. See, here they met inside. But let's see what happens now, okay? First, let's extend this side with dotted lines so we can draw this altitude coming straight down from this point. This is the first altitude that we would think about. Perpendicular. But then we can, of course, turn this triangle and draw an altitude this way. Okay. So that's the second altitude. Then we can, of course, turn this triangle and I'm getting confused here. And draw this altitude, right? If we extend this side, we can draw an altitude to this line from this point. So this is our third altitude now. Okay, and now watch what happens. I'm going to extend this altitude down, right? And I'm going to extend this altitude down. And then I'm going to extend this altitude. And you can see exactly what happens, where they all meet. This time, which is kind of weird, is that they meet outside of the triangle. So when you have an obtuse triangle, the orthocenter is on the outside. Okay? So that is card 32. Let's put that aside and let's work on card 33. Now, we're going to talk about an angle bisector. An angle bisector divides an angle into two congruent angles. Okay? And let's draw a picture of this on the back. You should be familiar with this already, but let's draw a picture. Okay, so say we have this angle here, right? Now, directly in between that, I'm just going to measure this angle real quick. This angle is about 43 degrees. So I'm going to go about half of that, so like 21.5 degrees. That's pretty much where my angle bisector goes. Okay, so an angle bisector, let's say that this was angle A, B, C, and let's say that some point out here is D. ray BD is an angle bisector if this angle here is equal to the congruent to this angle here. So angle ABD is congruent to angle DBC. So that means that it cuts that angle in half. So if this was 20 degrees, this would be 20 degrees. Okay? And that's it for this card. So now we're going to move on to card 34. The point where all three angle bisectors of a triangle intersect is called the incenter. Okay? The incenter is in the center of an inscribed circle within the triangle. Okay, so let's see what that means. On the other side, I'm going to draw one of my standard triangles, right? Nothing special about this. It's just a basic triangle. You can draw any one you want. I would draw it pretty big though, so that we can get a good picture of what's happening here. This time I'm going to extend. I'm going to make my longer side this side. Okay. So, if I look at this angle here, right, I want to draw the angle bisector. So I'm going to line up my protractor. And, whoops. And this angle is about 40, right between 41 and 42 degrees. So I'm going to make it 42. Okay, it's 42 degrees, so I'm going to go to 21 and just make a little mark, because that's where my angle bisector line is going to go through. So the angle bisector of this angle, right, over here, will go like that. So what we know, let me draw that a little darker. There's no reason for me to draw it light because we want to see that line. So that means that this angle right here is congruent to this angle. So we'll put one arc in each one of those. Okay? And we can label this if we want A, B, and C, but it's not going to really matter. Now I want to also draw the angle bisector of this angle, so I'm going to again do the same thing. Now this time this angle is pretty much 80 degrees. Okay, so I'm going to go to about 40, and I'm going to draw this angle bisector. Okay, so now I know that this angle right here, I'm going to give it 2 angle marks, is congruent to this angle. I'm going to give it 2 angle marks. They each get 2. Congruent angles get the same number of angle marks. So 1 and 1, 2 and 2. And now for the last one, I know it goes right through that point right there. So I'm going to draw it in without even measuring the angle. And so now this angle, I'm going to draw 3 angle marks on this side and 3 on this side. So these 2 angles are congruent, these 2 are congruent, and these 2 are congruent. I have 3 angle bisectors, and they all meet at this point right here, which is called the in center. Now let me show you what I mean about this last statement. The in center is the center of an inscribed circle within the triangle. Okay, so what that means is that if I was going to draw a circle, it would be the center. If I was going to draw an inscribed circle, okay, the in center would be the center of it. Now, if it was drawn perfectly, it would touch there. It would touch at 3 places. So I'm just going to fudge it a little bit so that it looks right. Okay? So the in center is the center of an inscribed. That means the circle is inside the triangle. Inscribed inside. You can think of that way. Okay? So that is card 34. Let's move on to card 35. Sharpen my pencil real quick. Actually, I don't need to. Okay. Alright, so a perpendicular bisector cuts a segment in half and is perpendicular to the segment. This is card, what did I say, 35. Okay, now, let's draw a picture of this. Excuse me. If we have a segment, just like that, okay, let's call this point A and this B. Now I drew this about 8.4 long, so I'm going to go to 4.2. That's halfway. Okay, make a little mark. And it's perpendicular, so I'm going to go 90 degrees. Make a mark. And I'm going to draw my perpendicular bisector. Right there. So let's say that this line is line L. We know that this is perpendicular. I measured it to be 90 degrees. And we know that this piece is equal to this piece. So we can say line L is the perpendicular bisector of segment AB. Okay, I'll show you why we wanted to know that. I mean, you need to know that, definitely. Now let's go to card 36. The point where all three perpendicular bisectors of a triangle intersect is called the circumcenter. Just give me one sec. I think we forgot to put something on. Oh yeah, on card 34, right? Let's put the incenter is always inside the triangle. Okay. And for this one, the next point is that the circumcenter is the center of a circumscribed circle about the triangle. Okay. And finally, the circumcenter, let me see how we put it on the last card, may be inside or outside of a triangle. Okay, now this one looks pretty cool. I'll show you how to draw this. Alright, we're going to need to make two drawings. Okay, so first I'm going to make about 1.5 inches long base for my first triangle. Okay, let me just double check that. Actually, I'm going to make it a little longer than that. I'm going to make it about 2 inches long. Okay, and then I'm going to make the rest of my triangle. It's going to be your basic acute scalene triangle. Or the angle, acute means all the angles are less than 90, and all scalene means all the sides are different, right? So now I have to draw the perpendicular bisectors of each side. Okay, so if this side is 2 inches, the perpendicular bisector is going to go right through here. And if this side is, let's say, 3.4 centimeters, I'm going to go to 1.7 That's going to bisect that side. And if this side is, let's see, about 4.6, I'm going to go to 2.3. Okay, and bisect that side. Now, not only that, but it has to be perpendicular, right? So if I go to that point I made and line up my protractor on it, I want to go to 90 degrees up. So I'm going to put a little mark there. Alright, so to perpendicularly bisect this side, actually that wasn't too great of a point, was it? I want to go like this. Okay, now this is perpendicular. It's 90 degrees, and it bisected this side. So that's one perpendicular bisector. Now I'm going to turn my triangle and do another one. Okay, now of course this isn't going to be perfect, but it should be pretty close. That's my second perpendicular bisector, so I know this is perpendicular. And I know that, let's see, this side, this whole side is congruent to this whole side. And now to draw my third perpendicular bisector, I know it's going to go right through that point. And just give me a sec here. And it's got to be perpendicular. And it's going to cross just like that. And this side is congruent to this side, and this is 90 degrees. And they're all going to meet at this point, okay, which is called the circumcenter. Now watch what's special about this point. It's the center of a circumscribed circle. And you'll see what that means in a second. It looks like I'm farthest from this point here. So I put my compass point on the middle of that circle, and I open it up to one of the vertex, and it's going to cross each vertex. One at a time. See that? You see how that's a circumscribed circle? It's on the triangle is inscribed inside the circle, or in other words, the circle is circumscribed around the triangle. Okay? So that's an example of when the circumcenter is inside of a triangle. Now another case could be when I want to draw now another triangle, but this time it's going to be an obtuse triangle. Okay, and you're going to see that this time the circumcenter is going to be outside of the triangle. Now, let's do all our perpendicular bisector stuff. So, if this is about 4 right here, then 2 is here. And if I was going to draw a perpendicular bisector, I'm just going to try to eyeball this and make it go straight up. So it looks like that's about right. Okay. Now I'm going to I'll go to this side over here now. Oh, and let me make this perpendicular, and this side is congruent to this side. Now, this is about 5.4. So at 2.7, I got to make a perpendicular line here. Okay, and then let me draw my perpendicular symbol. And this side is congruent to this side. And finally, I'm going to perpendicularly bisect this side. Let's see, this looks like it's 2.6, so I'll go to 1.3. And if I go straight up, and if I did everything perfectly, it will cross all at the circumcenter. And this is perpendicular, and this side is congruent to this side. Now, you see how the circumcenter, I'm sorry, is outside of the triangle if it's obtuse. Now let's draw the circle. Okay. So I put the compass on the point and I open this up so that it's on one of the vertexes, and I go around. And it should be right on or very close to all of those vertexes. And this time it was right on. See that? So that circle is circumscribing that triangle. So this is called the circumcenter. Okay? So let's put that card aside. That was card 36. Alright. And that's about everything we need to know as far as the incenter, circumcenter, centroid, and what was the other one called?